In our lower classes, we have studied how to solve the system of linear equations or pair of linear equations using various methods such as substitution method, elimination method and cross multiplication method. So now we are going to study how to solve this pair of linear equations or the system of linear equations using determinants, and this method is called the Cramer's rule or the determinant method. Okay, so let's see how to solve the system of linear equations using this determinant method or Cramer's rule by taking an example. So I've taken the two equations over here, 3x plus 4y is equal to 7 and 7x minus y is equal to 6. So I will take the first determinant, I will name it as delta. So delta is equal to determinant of all the coefficients. Okay. So first column I will take the coefficients of x. So we have 3 and 7 are the coefficients of x, and second column we have coefficients of y, that is plus 4 and minus 1. So now let's calculate what is this determinant value. So 3 into minus 1 is minus 3, minus 7 into 4 is equal to 28. So my answer over here is minus 31. Okay. So next step, I will find what is delta x. Okay. For this step, what I am going to do here is I am going to replace the column, the first column, by these constants. So let's replace the column with these constants. So what happens? We get 7 and 6 in the first column. Second column, I'll keep it as it is. So 4 minus 1. So let's calculate the determinant value here. This is 7 into minus 1 is minus 7, minus 6 into 4 is 24. So we get minus 31 as the answer. So similarly, I'll replace the second column with this constant. I'll keep the first column as it is. So 3 and 7 as it is. Now let's replace the second column with these constants. So we get 7 and 6 over here. So this is equal to 6 into 3, 18, minus 7 into 7 is 49, and answer here is minus 31. Now how to calculate the value of x and y is x is nothing but delta x divided by delta. Okay, so let's calculate delta x. We have delta x is minus 31 divided by delta is again minus 31, and the answer will be equal to 1. So we got x is equal to 1 as the answer. So now let's calculate y. Similarly, this is delta y divided by delta, and that will be equal to delta y value is minus 31. So we get minus 31 divided by minus 31 is equal to 1. So we got x equal to 1 and y equal to 1 as the solution for this pair of linear equations. Now let's see if this answer that we have got is right or wrong. So I'll take the values of x and y and substitute in any one of these equations. Okay, so let's substitute in this equation. So 3 into my x value is 1 plus 4 into again y value is 1, and the answer over here is 3 plus 4, that is equal to 7, and it is same as the right hand side over here. So what answer we have got is correct. Let's take another example. So I have two equations, 2x plus 3y is equal to 11 and x minus y minus 3 is equal to 0. So in the first step, I'll write this equation, the second equation, as x minus y is equal to 3. Okay, so let's take these two equations and solve the system of linear equations. So first step, I'll find the value of delta. Delta is nothing but determinant of the coefficients. So in the first column, I'll take the coefficients of x, so 2 and 1. Second column, I'll take the coefficients of y. We have 3 and minus 1. So 3 and minus 1. Let's find the value of the determinant. So 2 into minus 1 is minus 2, minus 3 into 1 is 3. So we get minus 5 as the answer. Second step, let's find what is delta x. Now, when finding delta x value, we replace the first column with the constants. So, the constants over here are 11 and 3. So, 11, 3. Second column I will keep it as it is, so 3 minus 1. So, we get 11 into minus 1 is minus 11 minus 9. So, we get minus 20 as the answer. So, next let us calculate delta y. So, for this I will keep the first column as it is, the same column as it is in delta, and second column I will replace with the constants. So, 11 and 3. So, we get 3 into 2, 6 minus 11. So, this is minus 5. So, now to find the value of x, I will divide delta x divided by delta. So, we get minus 20 divided by minus 5 is equal to 4, and y is equal to delta y divided by delta, that is minus 5 divided by minus 5 is equal to 1. So, we got x is equal to 4 and y is equal to 1 as the answer. So, to verify if this answer is correct or not, you can substitute the values of x and y that you have got in any one of the equations given in the question and check if left hand side is equal to right hand side. Next, let us see what is the minor of an element in a square matrix. So, we have the definition of the minor of the element given by if A is any square matrix, and remember it has to be square matrix because we are discussing determinants here. Okay? So, if A is any square matrix, then the minor of an element Aij of the matrix A is the determinant obtained by deleting the row and column of the matrix A in which the element belongs, okay, to which the element belongs. And cofactor is given by this formula. It is represented or denoted by Aij, and it is nothing but minus 1 to the power I plus j. I is the position of the row, which row it is, the element lies, and j gives the column in which the element lies into the minor of Aij. So, let us discuss this taking an example. So, I have the matrix A, 3 cross 3 matrix. Now, to find the minor of 0, let us find minor of 0. We have 0 over here. Okay? So, you know the position of the terms, correct? So, first row and which column? Third column. So, first row, third column. Alright? So, minor of 0 is obtained by how? Deleting the row and column of A to which the element belongs. So, let us delete the row and column to which 0 belongs. So, if we delete this, we have 3, minus 4, 5 and minus 3. So, let us write the determinant. After deleting this, we get 3, minus 4, 5 and minus 3. Okay? So, let us calculate this. This is 3 into minus 3, minus 9. Minus of 5 into minus 4 is minus 20. So, minus into minus becomes plus. So, we get plus 20 and the answer is plus 11. Okay. So, now let us find the cofactor of 0. Cofactor of 0. As I told you earlier, it is in the first row and the third column. So, you know I value is 1 and j is equal to 3. So, let us substitute these values of I and j in the formula here. So, we get minus 1 to the power I plus j. So, 1 plus 3 into minor of 0. So, minor of 0 is 11. So, minus 1 to the power 4. 4 is even. So, minus 1 raised to the even number is positive. So, we will get plus 11 as the answer. Now let's find the minor of any other term. Let's take 3, okay, and find the minor and cofactor. Okay, so I am going to take this number 3. The position is second row, so row is 2 and column is 1. So this is nothing but I and j. Okay, so let's find the minor of 3. So what do? So we have to delete the row and column in which the number 3 belongs. So second row, first column, and write the remaining terms. So 2, 0, minus 3 and 4. Okay, let's calculate the determinant. We get 4 into 2 is 8 minus this is 0. So answer is 8. Okay. Now let's find the cofactor of 3. So this lies on the second row and first column. So I is 2 and j is 1. So let's substitute in the formula. So minus 1 to the power I plus j. So 2 plus 1 into minor of 3 is 8. So we get minus 1 raised to 3, the odd power here. Okay, so when minus 1 raised to the odd power, we get minus as the answer. So answer here is minus 8. Okay, so cofactors are nothing but minors with the proper sign. Now let's see the signs of the cofactors of the determinants of order 2 and 3. So I've taken a 3 cross 3 general matrix. Okay, so let's just find out the signs of the cofactor. So the cofactor of A will have certain signs, correct? So let's calculate. So 1 plus 1, this will be minus 1 to the power 1 plus 1, that is 2. It is even, so it will be positive. So the first position gets positive. Second, we have 1 plus 2, that is 3. So minus 1 to the power 3, odd power, so we will get minus. Similarly, this will be even, so positive. This is odd, negative, positive, negative, positive, negative and positive. Okay. So you can see the signs are alternative. So let's take a 2 cross 2 matrix and check what we get. This is A11, A12, A21, A22. Okay. Let's see what signs we get in the cofactor of this matrix. So we will get 1 plus 1 is 2, even, so we get positive. This is negative. This will be 2 plus 1, 3, so negative and positive. So it is important for us to remember the signs of the cofactor matrix, okay, in order to solve the problems. Next definition, adjoint of a square matrix. It is denoted by adjoint A, you read it as adjoint A. So if A is any square matrix, then adjoint A is nothing but the transpose of the cofactor matrix. So when solving the problems, first we will find what is a cofactor matrix and then let's take the transpose, and that is nothing but the value of the adjoint of A. Okay. So let's take an example taking a 2 cross 2 matrix. So I'll take a matrix, say A, B, C, D. So I've taken the matrix A, 2 cross 2 matrix, A, B, C, D. So let's find the cofactor first. Okay, so we have adjoint of A. So our question is to find adjoint of A. So adjoint A is nothing but the cofactor of A transpose. Okay, so let's find cofactor. So that is equal to, now we have already seen the signs, correct? And in a 2 cross 2 matrix we got this is A11, so this was positive, this was A12, so this is negative, A21 negative, A22 positive. Okay, so you have to remember the signs over here. Alright, so this is plus. Okay, so let's take the determinant now. We are using the definition of the cofactor. Okay, so this is, that is minus 1 to the power I plus j into minor, correct, minor of that element. So let's find this part we have already solved, so let's find the minor. So we are deleting the row and column which contains this A, so we have to calculate the determinant of D. There's only one element, this is a 1 cross 1 matrix, so the determinant is itself, so we will get plus D. So second element has a minus sign, so let's delete the first row and the second column. We have C remaining, so this is minus C. Next has a minus sign, delete this, we have B. Okay, then next we have a positive sign, delete this, we get A. So this is the cofactor matrix and we are taking the transpose of it. And what is the meaning of transpose? We are making the rows into the columns. So first row becomes the first column, so D minus C. Second row becomes the second column, minus B plus A. Now compare, now this value is adjoint of A, correct? Now let's compare the matrix A with the matrix adjoint A. Now what has happened here? Check this. A and D have interchanged their places, okay? And B and C are in their own places with a negative sign. So signs are changed. So the shortcut to find the adjoint of A is, if you have a 2 cross 2 matrix A, B, C, D, we will interchange these two values. So we interchange the places of A and D, and here we change the sign. So if it is positive, you make it negative. If it is negative, we make it positive. Okay. Let's take an example. Let's take an example of another 2 cross 2 matrix. Let's take 1 minus 2, 3 minus 4. Okay. Let's take this as the matrix A. So we have the matrix A, 1 minus 2, 3 and minus 4. Let's find the adjoint. So adjoint of A is nothing but, what do we do? Using the shortcut, we interchange, see, we interchange these two values. So let's interchange the values first. Interchanging these values, I get minus 4 over here and 1 over here. Now with the remaining terms, I keep the terms in their own places but change their signs. So this was negative, so I make it positive. This was positive, I make it negative. So we get the adjoint of A, adjoint matrix, to be this. So this is the shortcut to find the adjoint of A without finding the cofactor matrix, and this is applicable only for a 2 cross 2 matrix. For a 3 cross 3 matrix, there is no shortcut. You have to find the cofactor matrix and then take the transpose of it. So let's see that using one example. So we have a 3 cross 3 matrix. Let's find the adjoint of this matrix. So find adjoint of A is the question. Now adjoint A is nothing but the transpose of the cofactor matrix. So first I'll write this. Okay. Now let's find the cofactor matrix. So that is equal to the cofactor matrix transpose. Okay. So first I will write the signs, and you know that the signs are alternative, correct? So we have plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay. Now let's fill this term. This will be the minor of the first term. So determinant of, delete the first row and the first column. We have minus 2, 0, 5 and minus 3, 5, minus 3. So second term, delete the first row and the second column, 3, 0, 4, minus 3, 3, 0, 4, minus 3. For the third term, delete the first row and the third column. We have 3 minus 2, 4, 5. So 3 minus 2, 4 and 5. So similarly, we will fill the rest of the matrix. Okay? So for this term, we delete the first column and the second row. We get minus 1, 2, 5 and minus 3. For the next term, we delete this. So 1, 2, 4 minus 3. For the next term, we delete this. So 1, minus 1, 4 and 5. Next term, we delete this. Minus 1, 2, minus 2, 0. Determinant of 1, 2, 3, 0. The next one, determinant of 1, minus 1, 3 and minus 2. Okay. So now let's find the values of these determinants and then we will get our cofactor and hence the adjoint. Okay. So we have, this is equal to, we have minus 2 into minus 3 is a plus 6 minus 0 is a 6. Now don't forget to multiply the sign that is outside the determinant with whatever answer you get over here. Okay. So in this case you see 3 into minus 3 is minus 9. This is 0 minus 0, but there is a sign outside here, minus sign outside. So the answer is minus 9 into minus 1. So you get plus. So plus 9. Here in this case we have 3 into 5 is 15 minus, this is minus 8. So it becomes plus 8. So 15 plus 8, answer is 23 and there is a positive sign. So 23. Okay. Next we have minus 1 into minus 3 is plus 3 minus 10, plus 3 minus 10 is minus 7, but there is a minus sign outside. So minus into minus becomes plus. So we get plus 7. Next term we have 1 into minus 3 is minus 3, minus 3 minus 8 is minus 11. Plus we have plus here, so we get minus 11 over here. Next we have minus sign outside the determinant. So this is 5 plus 4, correct? So we get 9, but there is a negative sign, so minus 9. Next term 0 plus 4, so it is plus 4, plus into plus is plus, so we get plus 4. Here 0 minus 6, but there is a minus sign outside, so we get plus 6. For the last term, we have minus 2 plus 3, that is 1, and there is a positive sign, so answer remains plus 1. Okay. So now let's take the transpose of this matrix. So the first row becomes the first column, so 6, 9, 23. Second row becomes second column, 7, minus 11, minus 9, and third row becomes the third column, 4, 6 and 1. Okay. So this is how we find the adjoint of a 3 cross 3 matrix. Let's consider another example how to find the adjoint A of a 3 cross 3 matrix. So given the matrix, first I'll write the formula. Adjoint A is cofactor matrix, cofactor A transpose. So let's find the cofactor matrix. First I'll write the outline, I'll draw the outline how the matrix should look like. Okay. Next we will put the signs, the alternative signs, plus minus plus, minus plus minus and plus minus plus. Okay. Now let's fill in the terms. So we have determinant of, delete the first row and first column. So we have 4, 7, minus 1, 1. Next term 3, 7, 1 and 1. Next term 3, 4, 1, minus 1. Now delete the second row and the first column. So we get 1, 1, minus 1 and 1. Next term we have 1, 1, 1, 1. Next term we have 1, 1, 1 and minus 1. So for the last row we delete this, we get 1, 1, 4, 7. Next term 1, 1, 3, 7. Next term, this is plus 1, 1, 3 and 4. Okay. So now let us calculate the values of these determinants. We get, this is 4 plus 7 is 11. Here 3 minus 7 is minus 4, but there is a minus sign outside. So minus into minus gives plus. Here minus 3 minus 4 is minus 7. Okay. Do not forget to write this transpose. Next we have 1 plus 1 is 2, but there is a minus sign outside, so we get minus 2. Next term 0, next term minus 1 is minus 2, but there is a minus sign outside, so you get plus 2. Next term 7 minus 4, 3, so we get positive 3. 7 minus 3 is 4, minus 4. Here 4 minus 3 is 1 plus 1. So now let us take the transpose, and that will be our adjoint. Okay. So first row becomes the first column, so 11, 4, minus 7. Second row becomes the second column, minus 2, 0, 2, and third row becomes the third column, 3, minus 4 and 1. This is the adjoint of the given matrix. We have a note which says A into adjoint A is equal to adjoint A into A, and that is equal to determinant of A into I, where I is the unit matrix or the identity matrix of same order as that of A. So let us verify this using an example. So I have taken a 2 cross 2 matrix. So we need the adjoint. So first let us find the adjoint A. And how do we find the adjoint? We can use the shortcut. So we interchange these values. So after interchanging we get minus 6 and 2, and we change the signs. So it is plus 3 here. So adjoint will have minus 3. It is minus 4 here. So adjoint will have plus 4. Okay. So now let us find the values of A into adjoint A into A, and that is equal to determinant of A and into I. Okay. So first let us solve this. A into adjoint A. So this is equal to 2, 3, minus 4, minus 6 into the matrix minus 6, minus 3, plus 4 and 2. So let us multiply these two matrices. So row into these two columns. So 2 into minus 6 plus 3 into 4. Next term 2 into minus 3 plus 3 into 2. Next term second row with the columns. So minus 4 into minus 6 plus we have minus 6 into 4. So this becomes minus 6 into 4. Next term here, this row with the second column. So minus 4 into minus 3 minus 6 into 2. Okay. Now let us calculate the values. Here you get minus 12 plus 12, that is equal to 0, minus 6 plus 6, 0, this is 24 minus 24, 0, here it is plus 12 minus 12, you get 0. Okay, so you got A into adjoint A to be a 0 matrix. I will take this as equation 1. Okay, now let us find adjoint A into A. So let us take the matrix adjoint minus 6, minus 3, 4 and 2 and multiply this with the matrix A, 2, 3, minus 4, minus 6. Okay, let us multiply the first row with the first column. We get minus 6 into 2, minus 3 into minus 4, next term minus 6 into 3, minus 3 into minus 6. For the second row, we multiply the second row of this matrix with the columns. So, 4 into 2 plus 2 into minus 4. Let us multiply with the second column. So, 4 into 3, next plus 2 into minus 6. Now, let us calculate the values. Minus 12 plus 12, 0, minus 18 plus 18, 0, 8 minus 8, 0, here you will get 12 minus 12, 0. So, again you got the 0 matrix, I will take this as equation 2. So, from 1 and 2, from equation 1 and equation 2, you know that these two values are same. Now, let us find the value of determinant of A into I. So, let us find the determinant of A. So, determinant A is minus 12 plus 12, that is equal to 0. We are taking the identity matrix. It is told that the unit matrix should be of the same order as that of A. So, we will take a 2 cross 2 identity matrix. So, when I find determinant of A into I, it is nothing but 0 into this matrix, you will get a 0 matrix. Okay, let us take this as equation 3. So, from equation 1, equation 2 and equation 3, we can conclude that A into adjoint A is equal to adjoint A into A equal to determinant of A into I, and this is from 1, 2 and 3. Next question. Let us verify A into adjoint A is equal to adjoint A into A equal to determinant A into I for a 3 cross 3 matrix. Okay. So, first we need adjoint A value. So, we know adjoint of A is cofactor matrix transpose. Okay. So, we will first find the value of adjoint A. We have plus, minus, plus, minus, plus, minus, plus, minus, plus. Now, let us fill in these determinants. So, let us delete the row and column. We get 4, 7, minus 1, 1. Next term we get 3, 7, 1 and 1. Next term we get 3, 4, 1, minus 1. For the next term we have 1, 1, minus 1, 1. Next one, 1, 1, 1, 1. For the next term, it is 1, 1, 1 minus 1. Next one, 1, 1, 4, 7. Next one, 1, 1, 3, 7. and the last term 1, 1, 3, 4. Okay, so let's calculate the value of the determinants. We get, this is 4 plus 7 is 11. Here 3 minus 7 minus 4, but there is a minus sign, so you get plus 4. Next term we get minus 3 minus 4 is minus 7. Next term 1 plus 1 is 2, we get minus 2. Here we get 0, here we get plus 2. Here 7 minus 4 is 3. Here 7 minus 3 is 4. There is a minus sign outside. So this is 4 minus 3 is 1. So we are taking the transpose of this. So adjoint A will be equal to, let us make first row into first column. So 11, 4, minus 7. Second row into second column, minus 2, 0 and 2. Third row into third column, 3, minus 4 and 1. So this is the value of adjoint A. Okay. Now let us find the first part, A into adjoint A. So let us take A into adjoint A is equal to, substitute the matrices that's given and that we found out. So 1, 1, 1, 3, 4, 7, 1, minus 1 and 1, 11, minus 2, 3, 4, 0, minus 4 and minus 7, 2, 1. Okay. So let us multiply first row with all the columns. So we get 11 plus 4 minus 7. So you get 8. Minus 2 plus 0 plus 2, 0. Next we get 3 minus 4 plus 1, 0. So now let us multiply the second row with the first column. We get 33 plus 16 minus 49, 0. The next term minus 6 plus 0 plus 14 is plus 8. Next term 9 minus 16 plus 7 is 0. Here 11 minus 4 minus 7 is 0. Next we have minus 2, 0 plus 2 is 0. Next term we get 3 plus 4 plus 1, that is 8. So we got A into adjoint A is 8, 0, 0, 0, 8, 0 and 0, 0, 8. Now similarly, let us find what is adjoint A into A. So adjoint A into A is equal to, let us substitute the values, 11 minus 2, 3, 4, 0 minus 4, minus 7, 2 and 1 into the matrix A, that is 1, 1, 1, 3, 4, 7 and 1 minus 1, 1. Let us multiply these two matrices. We get 11 minus 6 plus 3 is 8. Next term, first row with the second column, we get 0. Next, first row with the third column, 11 minus 14 plus 3 is 0. Next, 4 into 1, 4 plus 0 minus 4 is 0. 4 plus 0 plus 4. You get minus into minus is plus, so plus 8. Next, 4 plus 0 minus 4 is 0. Next term, minus 7 plus 6 plus 1 is 0. Minus 7 plus 8 minus 1 is 0. Now minus 7 plus 14 plus 1. is 8. So, we got the next matrix adjoint A into A is also same as the previous matrix. Okay. Now, let us find the last part, determinant of A into I. Okay. Let us take this as equation 1, equation 2. Now, let us find what is determinant of A. So, determinant A is equal to, we will assign the signs plus minus plus and expand this using the first row. We get 1 into, this is 4 plus 7 is 11. Next, minus 1 into, this is 3 minus 7 is minus 4, plus 1 into minus 3 minus 4 is minus 7. Okay. So, this is 11 plus 4 minus 7, answer is 8. So, we have to find what is determinant of A into I. So, it is equal to 8 into I. What is I? Identity matrix or a unit matrix of the same order as that of A. So, we will take 3 cross 3 identity or the unit matrix. So, we get 8 0 0 0 8 0 and 0 0 8. So, let us take this as equation 3. So, from equation 1, equation 2 and equation 3, we can conclude that A into adjoint A is equal to adjoint A into A, and that is equal to determinant of A into I. Next question, let us verify that adjoint of A into B is equal to adjoint B into adjoint A given the matrix A and B. Okay. So, let us first solve the left hand side. For the left hand side, we need A into B. So, first let us multiply A and B. So, we get 2 minus 3, 1 minus 6 into minus 1, 4, 1 minus 2, that is equal to 2 into minus 1 is minus 2, then minus 3. Next term, this is 2 into 4 is 8 plus 6. Next term, minus 1 minus 6, and the next term 4 plus 12. So, this is equal to minus 5, 14, minus 7 and 16. Okay. Now, let us take the adjoint of this matrix. So, adjoint of 2 cross 2 matrix, we have already studied the shortcut. What do? We interchange these terms. So, first let us interchange and write. So, 16 and minus 5, and for the rest of the terms the signs change. So, plus 14 becomes minus 14 and plus 7 minus 7 becomes plus 7. So, we have equation 1 our left hand side. Okay. Now, let us find what is adjoint B into adjoint A. So, first let us find what is adjoint B. So, adjoint B is equal to, we interchange these two terms. So, we get minus 2 minus 1, then change the signs 4 and minus 1. Adjoint A is equal to, again same method, minus 6 2 and change the signs, you get minus 1 plus 3. Now, let us multiply these two matrices. Adjoint B into adjoint of A is equal to minus 2 minus 4 minus 1 into minus 6 plus 3 minus 1 and 2. So, now let us multiply these two matrices. So, we have, we will multiply the first row with the first column, we have minus into minus plus. So, 12 plus 4 next term minus 6 minus 8, next term 6 plus 1, and the last term you have minus 3 minus 3 minus 2. So, that is equal to 12 plus 4 is 16, this will be minus 14, this is 7 and minus 5. So, I will take this as equation 2. Now, compare equation 1 and equation 2, they are equal. So, from equation 1 and 2, we have verified that adjoint of A into B is equal to adjoint B into adjoint A. So, let's write hence or therefore adjoint of A into B is equal to adjoint B into adjoint A.